How can you understand all the patterns in Pascal's triangle? Imagine a triangle made of numbers that keeps revealing new secrets the more you look at it. That's what Pascal's triangle is all about. It's a simple shape but hides many fascinating patterns. To understand these patterns, start with how the triangle is built. Begin with a single one at the top. Each new row starts and ends with 1. Inside the row, every number is the sum of the two numbers right above it. This simple rule creates the entire triangle. Now, each row of Pascal's triangle matches the coefficients in the expansion of a binomial expression. For example, the third row, which is 1, 3, 3, 1, shows the numbers for the expansion of a plus b cubed. This connection helps us see why the triangle is so useful in algebra and counting problems. When you add up all the numbers in a row, the total always equals to raise to the power of that row number. For example, the fourth row sums to 16, which is 2 to the power of 4. This links Pascal's triangle to exponential growth and powers of 2. Another interesting pattern appears with prime numbers. If the row number is a prime, then all the numbers inside that row, except the ones at the ends, are divisible by that prime. For example, in row 5, the numbers 10 and 10 are divisible by 5. This shows a connection between the triangle and number theory. You can also find Fibonacci numbers by adding numbers along certain diagonals in the triangle. These sums produce the famous Fibonacci sequence, which appears in nature and art. Each number in the triangle also represents how many ways you can choose objects from a larger set. This is called combinations, and it helps solve many counting problems. There is also a pattern involving powers of 11. The numbers in each row, read as a single number, match 11 raised to that row's power. For small rows, this works perfectly, but for larger ones, you need to carry over digits. To understand all these patterns, try building the triangle by hand. Look at how each number is formed and explore the connections to algebra, prime numbers, Fibonacci, and combinations. Practice expanding binomials using the triangle and see how the patterns emerge naturally. Study the divisibility rules and how the numbers relate to prime numbers. Trace the diagonals to find Fibonacci numbers. Use the triangle to solve real counting problems and see how these patterns are all connected. Pascal's triangle is more than just a shape of numbers. It's a window into many parts of mathematics. Its patterns show us how simple rules can create complex, meaningful relationships between numbers. This makes it a fun and powerful tool for anyone curious about how numbers work together in patterns and sequences.